you can be active in shaping this new process or passive. And I think it's really important that especially architects are very active in this process.
Welcome to Dialogues in Design. Today we are going to be talking to Moritz Rietschel. Moritz is the co-founder of Revin, building at the frontier of AI capabilities and CAD. His work builds on research at UC Berkeley from early 2024, bringing early LLMs into CAD as AI collaborative tools with Professor Kyle Steinfeld and robotic fabrication with Professor Simon Schleicher. Moritz has lectured internationally on AI-based creative tools, published at Academia and the IGAC Journal, hosted workshops at MIT and Tongji, and contributed to international research conferences. Moritz, thank you so much for joining us at Dialogues in Design today. It's a pleasure to have you here.
Thank you for having me, Nikita.
So as we begin, I would love to know your journey into architecture. How did it begin?
My journey into architecture. Interesting. I guess in my background, I've always been interested in making things from a young age. If that was like Lego or the wood shop or working with clay or a 3D printer even. So I was into CAD and 3D modeling and making objects of all kinds of sizes from a young age. And then I have an older brother who went to study architecture. And then in my Easter break and after school and on the weekends, I would go and build his models, help him build the models. So that was a pretty easy way to get into architecture.
Wow, that sounds very interesting. So as you were mentioning that you would help your elder brother out, was there a specific project or moment where you thought that designing buildings is the thing for you? And how do you see it differently today?
I guess I never thought the task of designing buildings was for me. What I thought was interesting was the kind of education that architecture gets you and the breadth of it. So that it's the fact that it's project based and you work on your own projects from the start. The fact that it mixes kind of an intellectual pursuit as well as a craft and like material and engineering side of it. They're very it's a very multifaceted thing. And I thought that would that was very attractive to me. But yeah, I actually, even today, am not designing buildings. So I don't think that has changed that much. I guess I was very interested in the act of making across industries and sizes and scales. And now that's also something that we work on. We just help people make things instead of making them ourselves.
Yes, definitely. We are coming to what you are building. But before that, right now you're very much into research. So at what point in your academics or afterwards did your research actually attract you and it became central to your practice rather than just an exploration?
That's a very good question, I think. I guess I was always fascinated by emerging technologies. And even while I was still at school for my undergrad, I would build projects around papers that I found. At the time, there was a lot of MIT self-assembly lab things, anything from they had a lot of different projects, but at all scales. And I thought they were very interesting. They had some knitting projects that I thought were awesome. They collaborated also on architectural scale with ETH at the time, Mariana Popescu. And it was kind of a mix of bringing like digital technologies into new making processes, which was always exciting to me. And then I would try to spin my projects around those speculative or emerging technologies. And then at the very end of my undergrad, I went all in on one of those projects that they did, which was called liquid printing. And it's kind of a new way of 3D printing where you print in a gel matrix. It isn't originally invented by them, but they did a paper that very well describes and was very popular how to do it. So I took that paper and then spent a year rebuilding everything from scratch in my lab. So at the time I was working in a robotic fabrication lab. The 3D printer was kind of solved because we had a 6-axis robot arm that I knew how to program and I spent a lot of time on already. So then it was all about the hardware. How do you extrude which materials into what gel matrix and so on. And the kind of new design possibilities that it opens up, because I was building a machine that didn't exist, that nobody else had. And then immediately I was wondering about how can I design with it? So I guess that in itself is research, because I was taking something that was kind of on the forefront and emerging, and I was appropriating it, and it put me in a weird place where I could design for machines that nobody else had. So I would go and sketch in VR like a robotic toolpath for something that then gets printed in a scaled down mode. So I could like move the robot just by sketching, like not in real time, but still I could like plan the toolpaths just by moving my hand and stuff like that. So I think I was just interested in the stuff that's emerging, which made me like reproduce them or try to recreate the stuff that I saw in the paper, which then put me in a place where I was suddenly doing things that nobody else had done because nobody else had these machines and Also, I was very lucky to be in a great environment at university where that was possible, where I got access to these kinds of machines, which I know that is very unusual. And I would go in to work on the robot after office hours and on the weekends when the PhD students weren't there. So it was very much like an after-hour night science kind of thing. But that put me, like, it was then, I guess, kind of research because it just didn't exist yet. And yeah, I guess then to go to grad school, it was really important to me that I could keep working on emerging things, stuff that I know is interesting because you can figure out new things and you can think about things that just were not possible to think about before or like didn't make any sense. So I thought it was very interesting. And for grad school, I tried to go somewhere where that was possible, like very explicitly, because I'm still not designing buildings, right? I'm not a very good building designer, but I'm interested in processes of making, and especially in the age that we're in right now, like their digital technologies are really, really powerful, but very, very hard to actually bring them to bear fruit in like real life on the one hand, and then also like in commercial projects on the other hand. So both of those things are very hard, even though the digital technology is very powerful. And I guess that's an unsolved problem, but something that I will keep working on.
That's such a wonderful journey. I love how you put research as something that you're working on which doesn't exist. If you were to
Mhm.
define research, how would it be? Would you define it as an exploration, problem solving, something else?
This is a very interesting question because I'm probably the wrong person to answer it. But there's a lot of discussion, I guess, and like an intellectual tradition around design and design research and design as research. And I'm really I'm not very good at this theory things. I'm not very theoretical. And so you can probably find a lot of better answers. But I think a lot of design, it's just problem solving, right? So it is unique in that the constraints are unique and you're making something that doesn't exist yet. But the things that you discover are things about your specific problem, and they're maybe not so general, right? So you design the optimal building for a given context and you discover something new about it, right? But it's like if you want to call it research in an academic setting, you need to go beyond that. But it's actually not that different. You just figure out things about problems that are more general, whereas design is very specific, at least the way that I think about it. You usually have a very specific problem, and research problems, I guess you have more open problems. But otherwise, I don't think that they're so different. And a lot of the ways that you think about designing actually maps quite well and is good to bring into research, in that you just, you try things out and you're surprised. You allow yourself to discover things that you didn't expect to discover.
I wanted to know your perspective on being a researcher and a designer. So now coming to the tools that you have built, what was the original
Mhm.
spark behind Raven? Was there any opportunity or was there frustration as a designer? What was the opportunity that you took?
It's also something, I guess, that evolved over time, and it took a while to materialize into Raven. But a core thing that I like remember all throughout my education and work experience is how powerful the tools are and how nobody can use them. So everybody has Rhino installed. Almost no one can use Grasshopper, and definitely nobody can use like this one complex plugin that solves a problem very well within a given university or even the universities I went to. And so even though things are possible to do, they're extremely difficult to learn and to get done, right? And so this mismatch, I could see that by like other students spending a lot of manual work on something that some of the the few students in every year that are Grasshopper savvy could just script um, and free up that time for other things. I always thought that it was a bit sad, but then at the same time, like sad in the sense of like, there's a problem to be solved. There are great tools that would be useful to use. I'm not saying you need to do everything, everything needs to be a computational tool. It doesn't, but they are useful at times. And it should be like this barrier of using them, I guess, is a big problem. And I've always known that. I've taught other people how to use Grasshopper and stuff like that. And it's just difficult if you're a designer because it's a very different way of thinking. And it's hard to leave this direct modification interaction way of thinking behind. And that's okay. I think that's fine. I don't think like there's maybe a little bit of an arrogance or a stigma around the parametric design, where on one hand, people who do think like in algorithms and programmatically think that like everybody else is just like stupid or something. I don't know. Like you see this a lot, where it's like I guess I was the same. It just learned Grasshopper, and to me it came naturally, and I also program, and so for me it wasn't so strange, whereas for others it's really strange and very different from how they work. And then people who don't work with tools like that feel like, oh, that's just not for me, right? And then they don't even engage the tiniest little bit with Grasshopper because it has this like stigma, and taste of something that I don't know how to do. And then if they're confronted with a Grasshopper script and they don't immediately get it, then it's like a little bit of maybe a shame reaction or something, which I think is really sad because the tools are super powerful. Everybody, and like I don't blame the designer who doesn't know how to use Grasshopper, right? I think that's the problem. Like the tool needs to be designed in a way that people can use it, not designed in a way that you have to like study the tool and learn it really well and then you can use it, because it just locks out a lot of people. I guess like this is a problem that I've seen for a really long time. And then, a lot of other things came together to make Raven happen. At the core, like that's something that I think is very interesting. I want to help people use tools like that to make things happen, use them in their life, in their work, build better. And in order to do that, you need to make them more accessible.
Lovely how you mentioned about the ease of using the tools, because it's so that using computational tools is difficult. You need a lot of learning in it. The entire process seems tedious. Also, lovely how you spoke about the shift in thinking when using computational tools. So, how has your definition of good design changed since you started working with computational design?
I don't think it has. It doesn't matter if you use computation tools or not in your design. I think you can do design is also extremely general, and I don't think about it now just in terms of a building, but tools are just tools to help you do a good design, but whether design is good or not is not, I don't think is defined by the tools. People designed really, really well with a pencil and paper. So they were doing just fine. They were doing great designs. So just use the tools to do good design, but I don't think it changes just because the tools change.
That makes so much sense. So, coming back to Raven, what was the hardest part of translating a research driven idea into a product? How was your journey throughout?
So, what was the hardest part? It's always hard to start a company and to build a startup and to build something that is so good that people like it and they tell other people about it. I think it's always hard. And it's not particularly hard going from research into doing that compared to doing it in general. So, and we've been extremely lucky to have a lot of support, a lot of friends. We know the space really well. We were supported by my university. We were supported by our friends at different institutions, at firms, the people that like our product and talk about it. So I guess we've been super lucky that we have been able to do it. And I don't know if there was a particular aspect about it originally being research that made it difficult. I think we were lucky I was lucky to even be able to do research as a kind of to be published, to be heard, because the work that I was doing, honestly, the first time I presented at Arcadia, I presented my first paper, I thought it was the most, obviously, you always think the thing you work on is the most important thing, because otherwise, you wouldn't work on it. You work on something else. And at first, it felt like, no, other people didn't really think that for a while, right? 2 years ago, people did not think that AI was going to come into CAD or into Grasshopper or into their workflows beyond image gen. And they felt like image generation was also kind of where it was at the time, fine, and they didn't need more. And I guess it was hard to get actually into research. That was hard because you need to adopt a kind of style and way of expressing yourself and embedding it into historical references that other researchers like, right? It's kind of like a cult, but you have to learn the language of how research works and how publishing works and how academia works. And that's hard. I think it's hard. And you need good mentors to do that. And I was very lucky to have good mentors that helped me to do this and got, that I also published with and stuff like that. And it's hard in its own way. And then if you want to build a product and have people use it, that's also hard in a way. And it's hard in a very different way. Nobody cares about your references. People don't think that, don't really care about how interesting it is from an intellectual perspective. They just care about, does it help them, right? Very practical, very different kind of problem set.
Yeah, that's really true. As you mentioned, it's not a linear journey. There are lots of things involved. So, as you were talking about that, 2 years ago, people didn't imagine AI to do so much in architecture. So, what we are seeing AI can do is changing by the day. Was there something that Raven does today that you didn't expect it to when you started?
Fundamentally, I always thought about it as being like a geometry problem, making models, changing models, geometry. And what I found is that it's actually not just about geometry. The fact that we can support any work that happens in random Grasshopper. Sometimes, people just wrangle some data or they use plugins to run simulations. It has nothing to do with making new geometry, right? It's an analysis process. Sometimes it's like completely removed from any actual geometry. It's just a bit of logic that they need. So the breadth of the work that we can support, I think that was surprising, and something originally I didn't think about it that way. Originally, I thought about it being about like authoring geometry. But computation tools are a lot more than just authoring geometry, and I guess that's also what I didn't consider at the time, that we actually just support computation tools, no matter what you do with them, right? And also now from our users, we have a huge breadth of users, user base. I mean, across industries, across use cases, it's very interesting. It's also difficult because you don't know how to communicate all the different things you can do with Raven, but it's very cool. When I talk to our users, very interesting how many different ways to use Raven there are.
I think it's really wonderful how far you have come. I can't wait to see how it's going to evolve soon. I'm using it and really it has made my experience so good. So I can't wait to see what more you have. So I wanted to speak to you about your design process. So when you are designing a tool, when you're working on a tool, where do ideas usually begin? From observations, intuition, how do you generally start?
So when you start from scratch, it's very different than when you have a product. It's very, very different because originally when I built the first product, I was building for people like me, right? Which is a very good thing to do because you know your user really well because it's yourself. So I like to use Grasshopper. I want to use more of it, do all sorts of different things with it, learn more about Grasshopper. So I could build a tool that would just help me do that. And otherwise, if you build a tool for other people, it's very, very hard to do because you need to, like, you probably don't actually understand them and their process and the problem. So at first, I just built a tool for myself, and the team also, all of us have some kind of architecture background or I know Grasshopper and so on, at least from the original team. So all of us kind of know this space. And so we could build just a tool that like we know makes sense for these kinds of workflows. And now once you have the tool, people just come and they tell you what they do with it, where it works, what doesn't work, what makes it, like, annoys them, what they wish for. And so it becomes this feedback loop, which is a completely different process. It's completely different. If you don't have anything, and you need to design from scratch, you need to look, you're going to find a problem, right? I mean, that's how you design. You need to find a problem. You don't find a tool and then look for a problem to solve. Everybody knows this. You find people that have a problem. You try to understand their problem. That's how you build something. But if you know the problem yourself, that's great, and you can get started. And then you put it out there. And I regularly, talk to the people who use Raven a lot. They get an email from me. I have a call with them. We write down the things, and I email them a week later. Hey, the things that you asked for are fixed. We have some new features, and we just iterate in this process. And that's extremely powerful. And I'm very grateful that we can do that. But you can only do that once you have two things, a product and users. And if you don't have either, then you need to look at the problem and just only care about the problem, because everything else needs to build from that.
That makes complete sense, and it's lovely how you take feedback into consideration and your product is evolving. So, as you are designing
Definitely.
computational tools yourself and you are using so many of these computational tools, how do you see the role of architects evolving or changing than what it was probably 5 or 10 years ago?
I actually don't know how the role of architects is going to change. I think it's a very open, it's basically to be decided and something that is being decided at the moment. Basically, I don't know what it's going to become, and nobody really knows how it's going to change. But you can be active in shaping this new process or passive, and I think it's really important that especially architects are very active in this process. What I can already say, I guess, there are a lot of people who never use computational tools who use Raven and now use a lot of computational tools. So the scarcity of like knowing how to use computational tools is definitely going away, and that's going to change a lot of things. I think it's going to change a lot of things for the better. You can now build way better informed and make way better informed decisions early on. You can bring all kinds of analysis processes into the early design process where before they were sort of unimaginable, for example. Or you can try out more variation too. You can do more design space exploration, which I think is really important if you want to find better solutions. In general, we try to build a tool that if you are an architect and you use our tool, that you can do more with our tool. It should be about giving the architect more power, access to more tools to do more design space exploration. Other tools work in a different way. Sometimes people build tools to get rid of the architects. Like, that's the thing. Especially in the US, for example, architects are under pressure anyway as a profession, and people just try to like save money getting rid of the architect, and the result is like a terrible, terrible new buildings that everybody suffers from. So I think that's a big problem, and so we need to empower the architects to be much better, like deliver more value so that they become more important and not less important. And that's the kind of AI tool that we want to build. And that's the kind of role that I want for the architect to have. I want them to have a bigger influence than before, because we can like multiply their agency. I think that's the goal. And so that's where I hope things will head. And at the same time, it's being sort of negotiated as we speak by the things that architects do, things that how the market changes. And I hope architects embrace the future and the new tools and like explore this actively and not, let it happen to them. I think that's really important.
That makes complete sense, and that is really insightful. I love you spoke about this. I wouldn't say misconception, but this thought process that people have that computational tools can actually replace architects.
I think if you are an architect who feels threatened by computational tools, then you probably misunderstand your role, because the role as an architect, you're trained to make decisions and to have opinions and to shape the world around you. And a machine will not make those decisions. Like you can ask the machine to make those decisions, but the value lies in the architect making decisions. That like the design process is a process of making decisions, and you should be able to make better decisions and just like deliver more value because of the decisions that you make and the insights that you bring. That's the role of the architect. It's not to like sit there and draw lines in the CAD software from the 90s, like the role of the architect has changed, the pen and paper of the master builder all the way to like BIM software. But the point of the architect is to give shape to a project and evaluate it and make decisions. And I don't think that those, like, of all the things that AI can do, I think it's a lot worse at making design decisions than, for example, engineering. Engineering has a clear problem set. It's a lot easier to automate engineering than it is to automate design decisions. So I don't think computational tools, when did adopting computational tools ever replace architects? Like, that's just not true. Maybe it replaced cheap labor that was hired as architects to draw plans. And that's a problem. Like, I'm not saying that that's not a problem. That's definitely a problem. But the actual process that you're trained for at school to do as an architect is to make these decisions and to shape the world around you. And I think that's something that, like, it's like AI slop, like you can watch like a shitty AI movie and nobody will care about it because there's no intention behind it. No good decisions have been made. Like there's no, like the design personhood is absent from it. So maybe for a few years you can, I don't know, not hire a filmmaker and just do AI slop, but the value of it will decrease very rapidly because it will be everywhere. Same as with coding, right? All the things AI can code, the value of doing it will decrease. But if you're a really good coder, a really opinionated coder, make really good decisions, build really good architecture, so you can code a lot better and more using AI. And that's what we want to do for architects. The vision and the ideas that you have, that's why we build a tool that you're kind of inside of and not something that automates passively, right? We want you to give as much of your opinion into the tool as possible so that you can shape it, because that's your job. Basically, your job is to engage with that and bring in references and adapt to the unique project and so on. That's the kind of stuff that an architect does. So I really don't think this is something that AI will do. I think that repetitive tasks, and especially like engineering tasks, honestly, engineering tasks that are easy to evaluate, is it done right or not? Does the calculation work? That's fairly easy to evaluate compared to is this building great? Like, what makes this building great? It's a lot harder to evaluate. I think design, sort of opinionated design and craft of the architect is really important to preserve and to bring it sort of into the new tools. Yeah.
I think that's really well said, how you define the role of architects, architecture, and AI altogether. So, the next
Mhm.
set of questions is going to be to get to know you as a designer and a tool builder and an architect. So, if you weren't working in architecture or design, what do you think would you be doing?
I like to think carpentry, but it's probably not true.
That's wonderful. What is a piece of media like a book, a film, a game, or any artwork that has influenced how you think today?
So for media, there's a great book called Humanize by Heatherwick, also the founder of Heatherwick Studio. It's really cool, and it's about how to design things that people like. And I guess in the same vein, a secret design opinion that I have is most of the new buildings are actually not nice, I don't think. Even if they were made by some famous architect, I don't like most of the new buildings, and that's a shame. I think the stuff that we make is mostly boring.
Interesting why you say that, because I think there's a lot of digital tools and a lot of software is available right now at hands,
Hmm.
which is actually supposed to make the design process a bit simpler than how it used to be.
That's where we are right now. I mean, I hope we can get out of it. But a lot of things. I mean, one of them is the role of the designer has diminished. Architects have to work with the constraints that they're given, and I think in the past maybe there was more trust placed into an architect. They took over more risk, more of the actual process, and they were not sort of an afterthought. Nowadays, a lot of the times they're an afterthought. That's definitely one thing. And then I guess people don't dare very much. I think we could be more daring. It's kind of this problem where, you know, if you make something like big and great and daring, like let's say a new opera house or something, then it always goes over budget. It's too expensive. Everybody's super pissed off for a few decades, and then afterwards they love it. Like, I mean, that's true for like every big thing that was ever built. Like, it's a big mess, and then when it's done, everybody's happy. So we should just like be okay with that and be more daring. And I think the lack of uniqueness, of maybe also ornamentation, is something that I don't have no problem with ornamentation, but everybody seems to have a problem with it. Yeah, I think those things are like, people don't dare to do unique things. They don't dare to do things like differently. There's also a risk perspective. Obviously, like, I understand why we are where we are, but I don't like it. And so I'm not sure computational tools make things less complex. Or I think we have to get to the point where digital tools make it easier to build more uniquely and interestingly. I'm not sure if we're there yet. And also, at the end of the day, if the architect doesn't take on more of a role and becomes more important again, it doesn't really matter. Like, it doesn't really matter what, you know, new digital tools you invent if they don't actually get used. Like, if the architect doesn't even build most of the buildings anymore, but they're just like some real estate firm that just like does some basic boxes, then whatever you come up with doesn't really permeate through. So I think you have to realize that you work in a market economy where things have to meet the bottom line, and it's actually not the fault of the like, you can blame everybody else, but at the end of the day, the only thing you can do is like try to work within the system as an architect, I think, at least. Yeah, I think if the architects take on more of a role, or somehow leadership, stuff like that, it could be more interesting again.
That's very well put. Now, what would you leave? One piece of advice you would leave to young graduates, emerging professionals who are just navigating their foot into the field right now, who are experimenting with design tools, digital tools, and exploring their role in architecture.
So I don't know if I can give any good advice. I will answer your question, but I don't know either. And nobody really knows right now, I think, first of all. And yet I would say two things. Like, embrace sort of the new things early. I mean, the reason why we could build this tool and make something that people love is because I was just always playing with whatever the new thing was, right? I used to do robotic fabrication. Now I do AI tools and blah, blah, blah. So like, you kind of, if you stay up to date, I think that's really important, especially as things change so quickly. Right? Things change quickly, and you want to, especially if you're young, way to get into practice is by being able to engage with the new things, because that's the one thing, that's your one advantage to other people with experience, because they have experience with the past tools. Okay, so you cannot match their experience. You can only bring in something new. So if you engage with new tools, great. And then the other thing, I guess, also is like your basics to learn how real things are made, real objects. Go make something by hand, and remember that at the end of the day, like, you're just building a model, and there's also the real world. I guess going to these two extremes, like, go to the extreme real world and then go to the extreme like future digital whatever AI world. And I think that's probably the best basis.
It's amazing advice, and this conversation has been so amazing, especially talking to you about all the emerging technology, their role, and cleared so many of my misconceptions, and I hope for the audience too. Thank you so much for talking to us and sharing everything so honestly.
Of course, thank you for having me.